Welcome to the Deep Dive. We are back, and today we are looking at a topic that, frankly, usually makes people groan. It makes developers roll their eyes, and it makes managers nervously check their watches. We are talking about the eternal grinding friction between trying to go fast and trying to be safe.
It really is the defining tension of the digital age, isn't it? You
Yeah.
have this unstoppable force of market demand. Give me the feature now, meeting the immovable object of risk management.
It's the classic stereotype. On one side, you have the move fast and break things crew, the developers, the product owners.
Yeah.
Their job, they're measured on velocity. They want to ship.
Of course, that's their incentive structure.
And then on the other side, standing at the gate, usually wearing a metaphorical or sometimes a literal frown, is the security team.
The Department of No, that's what they always get called.
That's the reputation, isn't it? The Department of the people who, from the developer's perspective, exist solely to slow you down, to tell you why your brilliant idea is actually a massive liability, and to bury you in paperwork right when you're on the cusp of launching.
And, to be fair to everyone involved, that reputation didn't come from nowhere. For decades, the conventional wisdom in IT, in business really, has been that this is a zero-sum game.
Right.
You have a slider bar in your head. You can slide it towards speed, in which case you're being reckless, you're taking on risk. Or you can slide it towards security, in which case you're paralyzed by process. You can't have both.
It's the old pick two triangle.
Yeah.
Fast, cheap, good. And we've just always assumed security is baked into good. So if you want it, well, you have to sacrifice fast. It's just the cost of doing business safely.
Right. But today, we are looking at a stack of research specifically focused on Chapter 6 of our source material, which is all about integrating Infosec into the delivery lifecycle that says that entire mental model is it's wrong.
It's a complete myth.
Not just a myth, but a really dangerous fallacy. The data shows that the trade-off doesn't actually exist if you change how you work. You don't have to choose between fast and safe. In fact, and this is the really wild part, the research suggests you can't actually be safe unless you are fast.
Which is a complete inversion of how most large organizations, most enterprises operate today. It's totally backwards from their worldview.
It is. And that's really our mission for this deep dive. We are going to unpack how shifting security practices earlier in the process, what everyone buzzes about as shifting left, actually improves delivery performance. We're going to prove, using the data, that high-performing teams spend less time fixing security holes, not more.
I want to stick a pin in that because I found a statistic in the reading that honestly made me stop and reread the page. It's about the time spent on remediation, on fixing things. We'll get to the specific numbers in a bit, but it completely destroys the idea that thorough has to mean slow.
It's so counterintuitive, isn't it? We're conditioned to believe that checking things carefully takes time. Measure twice, cut once. But in software, checking things late takes exponentially more time. That's the crux of it.
And we also have a case study later on that I am genuinely excited to talk about because it involves the federal government.
Yeah.
And usually when we talk about the feds and software, we're talking about billion-dollar disasters or websites that crash on day one.
The healthcare.gov trauma is still very real for a lot of people in this industry, a cautionary tale.
Exactly. But this story is the opposite. It's about a team that managed to slash security compliance times, which usually take nearly a year, sometimes more, down to a matter of weeks, in what is arguably the most bureaucratic environment on Earth.
It's the ultimate litmus test. I mean, if you can make security fast and agile in the context of federal compliance, FISMA, NIST, the whole alphabet soup of regulations, then you can do it anywhere. There are no excuses left for the private sector after you hear this.
So let's get into it. And to do that, we have to start by really looking at the status quo, the way things are currently broken. And the source material starts by throwing a little bit of shade at the term DevOps itself.
Yeah, it's a fair critique. And it's an important one. Think about the etymology of the word, DevOps. It was a movement, a culture, born to bridge the massive gap between development, the builders, and operations, the people who run the thing.
Because they used to absolutely hate each other. It was a war.
Oh, it was total trench warfare. Developers would write code in their nice, clean environments and then just, throw it over the wall to ops. If the server crashed at 3 a.m. because of a memory leak, the developer was sound asleep. The ops person was the one with the pager getting woken up.
Right. So DevOps was about shared empathy, shared tooling, shared responsibility for the outcome.
Exactly. You build it, you run it. But who is missing from that compound word, DevOps?
Security.
Yeah.
Infosec.
They weren't invited to the party. We built this great new culture of collaboration between the people making the software and the people running the servers, but the people in charge of securing the data were left out in their own silo with their own processes.
Like we decided to renovate the house, and we knocked down the wall between the kitchen and the living room to create this great open plan space. It's beautiful. Everyone loves it. But we left the front door unlocked and didn't even tell the security guard we were doing construction.
That is a perfect analogy. That is exactly what happened. And while dev and ops started to merge and iterate faster, shipping code daily or weekly instead of yearly, Infosec was left holding their old playbook. They're still operating on a waterfall timeline while everyone else is sprinting in 2-week cycles.
And this mismatch, this process gap, leads directly to what the source calls the capacity crisis. Because it's not just about culture or attitude.
Yeah.
It's about cold, hard math. There is a ratio cited by James Wickett from Signal Sciences that paints a really, really grim picture of the security landscape.
This is the 1 to 10 to 100 ratio. And honestly, this is one of those stats that explains why your local CISO looks so tired all the time.
Okay, walk us through that. What do those numbers mean?
So in a typical large enterprise, for every 1 person you have in information security, you have 10 people in infrastructure or operations, and you have 100 developers.
1 to 100.
It's staggering. Just stop and think about the physical implications of that workflow. You have 100 people whose entire job is to write and ship new code. They are generating new features, new API endpoints, new database queries every single day. And you have 1 person, a single person, whose job it is to make sure none of that is dangerous.
It sounds physically impossible.
It is. Let's use an analogy to make it real. Imagine a busy airport, say JFK during the holidays. You have 100 passengers all rushing to catch the same flight. The plane is already taxiing on the runway, the engines are spinning up, and you have exactly 1 TSA agent.
Just 1 for 100 people.
1 person. And that officer is supposed to open every single bag, check every passport, do a full pat-down, and wand every single passenger.
Sure.
No chance. And if they actually try to do their job properly, if they actually inspect everything by the book, what happens to the flight?
It misses its slot. It's delayed for hours. The passengers are furious. The airline is losing a ton of money. The whole system grinds to a halt.
Exactly. So everyone hates the security guard. They're the bottleneck. So the pressure on that guard is immense to just wave people through, to do a quick spot check. You look fine. Go ahead. You look okay. Go.
Which is terrifying when you're talking about, customer data or financial systems instead of just luggage.
It's security theater. But with a ratio of 100 to 1, if you rely on manual intervention, if your entire security model relies on a human being reading the code to find the bugs, you are mathematically destined to fail. You physically cannot read code faster than 100 people can write it. It's a losing game.
So this creates the bottleneck. The developers are moving incredibly fast, generating this massive volume of work, and then it all slams into this tiny funnel at the very end of the process.
And that's the end of lifecycle problem. In the traditional model, or even in a DevOps model that forgets about security, Infosec only sees the software right before it goes to production.
The dreaded security review meeting that's on the calendar for 3 days before the big launch.
It is, without exaggeration, the most toxic meeting in the corporate calendar. The dynamic is just broken from the start. The developers have spent 3-6 months building this thing. Marketing has the press release queued up. The executives have already promised the revenue from this feature to the board.
A launch party is planned.
The launch party is planned.
Cool.
And then the security guy, the one in the 100, walks in and says, hey, I was just looking at this and I found a critical architectural vulnerability. You can't launch.
And then the screaming starts.
The screaming starts because the cost of fixing that vulnerability at that stage is astronomical. We aren't talking about changing a line of code. If it's a fundamental architectural flaw, you might have to rip out the entire database layer. You might have to scrap the feature and start over.
It's like building a skyscraper, finishing the penthouse, and then the inspector comes in on the day of the ribbon cutting and says, the foundation is cracked. You can't just patch that. You have to tear the entire building down and start again.
So what happens in reality 99 times out of 100? The business overrides security. The VP of product says, we accept the risk. They make the security person sign a waiver, an exception form, and they launch anyway.
Because the immediate, tangible business cost of delaying the launch is seen as higher than the theoretical future risk of a hack.
Until the hack happens, of course. Then everyone's priorities change. But you can see why the dynamic is so broken. Security is put in a position where they are the enemy of success. And developers are put in a position where they are incentivized to hide things from security so they don't get blocked at the last minute.
And the source makes a really important point that developers aren't doing this out of malice. It's not like they're trying to write insecure code.
No, not at all. Most developers want to do a good job. They take pride in their work. But they are often, through no fault of their own, ignorant of the specific risks. The source cites the OWASP top 10, things like SQL injection, cross-site scripting, broken authentication.
These are the greatest hits of how to get hacked, the classics.
They are. They've been on the list for 20 years, and yet they aren't always taught in a standard computer science curriculum. You can graduate with a degree in CS from a great university and never have successfully executed a SQL injection attack in a lab environment. You don't know what it looks like.
So you have developers who don't know what to look for, outnumbered 100 to 1, working under extreme deadline pressure. And of course, vulnerabilities are going to slip through. The system is designed for them to slip through.
Yeah, perfect storm.
So the status quo is we are outnumbered, we are involved way too late in the game, and we are viewed as the villains. It's a pretty bleak picture.
It's a recipe for burnout for the security folks and breaches for the company.
Okay, so let's pivot to the solution, because there is one. The source uses the phrase shift left. Now, I know for our audience, this is a very familiar buzzword. We hear it all the time at conferences. But I want to go beyond the buzzword. When we say shift left, in the context of this broken 100 to 1 ratio, what are we actually changing?
Well, technically, if you think of a timeline from left to right, where left is the idea phase and right is production, we're moving security controls from the far right to the far left, from the release phase to the design and build phases. But philosophically, I think more importantly, we are changing the entire mechanism of verification.
Okay, what does that mean? Mechanism of verification.
It means we stop relying on inspection and start relying on prevention. To go back to your airport analogy, inspection is the TSA guard searching your bag at the gate right before you board the plane. It's slow, it's manual, it's prone to error.
Yeah.
Prevention is designing a suitcase that is physically incapable of closing if you try to put a bomb in it. The safety is built into the object itself.
I see. Okay, that's a dramatic image, but I get it. The container itself enforces the rule.
Right. If the safety is built into the development process, into the tools the developers use every day, you don't need that massive, painful bottleneck at the end. The problem never gets created in the first place.
And this is where we get to that core argument that turns everything on its head, the one about speed and safety. The research found that building security in doesn't just make you safer, it makes you faster.
This is the data that validates the whole DevOps hypothesis. It's not just a nice idea. It's a measurable business advantage.
So here is the stat, the one that made me pause. High-performing teams spend 50% less time remediating security issues than low performers.
Let's just dwell on that for a second. 50% less time. Not 5%, not 10%. Half the time.
That implies that the low performers, the ones who are likely doing those big, heavy manual security reviews at the end, are actually spending more of their development cycle dealing with security problems. Their thoroughness is making them slower and less secure.
Because they are stuck in what we call the rework loop. Think about it from the developer's day-to-day perspective. If I write a piece of code today and I get feedback on it in 6 weeks during that big, scary security review, where is my head at?
You've completely forgotten that code.
Right.
You're working on 3 other projects. You'd have to go back and figure out what on earth you were thinking.
I have totally lost the context. So when the security team comes back and says, you need to fix this, I have to stop what I'm doing now. I have to shelve my current project. I have to reload the old project into my brain, figure out what I was thinking 6 weeks ago, and then try to patch it without breaking anything else.
That context switching is a huge productivity killer.
It's a disaster. It drags the whole team down. It's incredibly expensive. Now, contrast that with the high performers.
Okay, so what do they do?
If I write code today and an automated tool tells me 5 minutes later, right in my code editor, hey, you just used a function that is known to be insecure, what do?
You fix it immediately.
I fix it instantly. I'm still in the flow. The context is fresh in my mind. I fix it, I commit it, and I move on. The whole process takes maybe 30 seconds, not days of rework.
It's the difference between wiping up a spill on the kitchen counter the moment it happens versus trying to scrub a red wine stain out of a white carpet a month later.
Precisely. The shift left approach is just immediate feedback. It's continuous hygiene. And because you catch it so early, the vulnerability never reaches production. It never becomes an incident. It never makes a headline. It's just a typo that got fixed.
So this sounds great in theory. how do we actually implement this? The source outlines 3 specific tactics. And I want to get really specific here because our listeners are practitioners. They don't just want the philosophy. They want to know what to do on Monday morning.
Okay, the 3 tactics are security reviews, but done differently, deep integration of security people, and heavy reliance on automated testing. But the nuance is in how you apply them, especially with that 100-to-1 ratio in mind.
Let's start with security reviews. You just told me security reviews are this toxic bottleneck at the end of the process. How is this different?
The difference is scope and timing. You don't review the entire application at the end of 6 months. You review small features as they're being designed or as they're being built.
So you're working in small batches. It's the same agile principle applied to security.
Exactly. But there is a catch. You can't just have your one security person sitting in every single design meeting for all 100 developers. They'd have to clone themselves. They just don't have the time.
So how do you scale that? How do you make that one person effective?
You have to triage. You have to empower the development teams to self-assess risk. The source suggests you trust the developers to flag things that are inherently risky, but you have to give them clear guidelines.
Like a checklist.
Sort of. You say, hey team, if you are building a simple UI change, like changing the color of a button, just go for it. We trust you. We don't need to see it. But if you are touching the authentication system, or if you are handling personally identifiable information, PII, or if you are changing anything about encryption, that automatically triggers a review.
So you classify the risk of the work, you trust them with the small, low-risk stuff, and you focus your limited expert time on the genuinely dangerous stuff.
It's the only way to scale your experts. And that ties directly into the second tactic, integration. Infosec needs to be part of the daily rhythm of the team, not a separate, scary audit function that shows up once a quarter.
The source mentions having Infosec attend software demos, which I thought was a really simple but powerful idea.
It's brilliant. Most agile teams have a weekly or bi-weekly demo where they show off what they built in the last sprint. It's very informal. If a security engineer just sits in on that meeting, they can spot things immediately, in real time.
What would they be looking for?
Well, they might see a new feature and look at the URL in the browser's address bar and say, wait a second, is that a user ID in the URL? That looks like an enumeration risk. Could I just change that number and see someone else's data? And they can say it right there in the room while everyone is looking at the screen.
And it turns it into a collaborative discussion, a teaching moment, rather than a formal police citation. The developer can say, oh, wow, good catch. I didn't even think of that. I'll fix that this afternoon. And it's done. No drama.
It humanizes the security team, too. They become part of the crew, a helpful advisor, rather than the distant auditors from the ivory tower.
But the real heavy lifter, the only way to truly survive and thrive with the 100-to-1 ratio, is the third tactic, automated testing.
This is where we replace the tired, overworked manual guard with the tireless, efficient X-ray machine.
Absolutely. And we have to get a little technical here for a second. We are talking about integrating security scanning tools directly into the CI/CD pipeline, the continuous integration and continuous deployment pipeline. So just to level set for everyone, every time a developer hits save and commits their code to the central repository, a series of robots wake up and start working on that code.
That's a great way to put it. The first robot that wakes up runs what we call static analysis tools, das AST. These tools read the source code without running it. They're looking for known bad patterns. Did you hard code a password in the code? Are you using a function that is known to be vulnerable to buffer overflows? Simple pattern-based stuff.
Okay, so that's checking the blueprint. What about checking the actual building?
That's the next robot, das AST, dynamic analysis. This happens after the code is compiled and is actually running in a temporary test environment. The DAS tool acts like a dumb but very persistent hacker. It throws garbage data at the login form. It tries to inject SQL commands. It buzzes the application to see if anything rattles or breaks in an insecure way.
And there is a newer category of tooling that is critically important these days, especially with modern development. SEA, software composition analysis.
Oh, that is huge now. Probably the most important one. Modern software isn't really written from scratch anymore. It's assembled. You pull in dozens, sometimes hundreds, of open source libraries to do the heavy lifting: logging frameworks, web servers, image processors.
You're standing on the shoulders of giants.
You are. But some of those giants have cracked ankles. SCA tools scan your project and create an inventory of all those third-party ingredients. Then they check that inventory against a massive database of known vulnerabilities.
So it's like a food safety inspector checking your pantry. Hey, you're using version 2.1 of this log4j library, But version 2.1 has a known critical hole that lets hackers take over the entire server. You need to upgrade to version 2.2 immediately.
That is exactly what it is. And the magic of all of this is that it happens automatically on every single code change. If any of these tests fail, the build breaks, the pipeline stops dead, the developer gets an instant notification, usually right in their IDE or in Slack, saying, your build failed because of security error X.
So they can't even deploy their code to the main test environment, let alone production, until they fix the security issue.
It creates an automated quality gate that is objective, non-negotiable, and incredibly fast. And crucially, it gives that feedback only to the developer who wrote the code.
Why is that part so important, the privacy of it?
It's all about psychology. If I, the security expert, find a dumb bug in your code and I announce it during a big meeting with your boss and your whole team, you feel shamed, you get defensive, your ego is bruised. But if a robot sends you a private message saying, hey, you messed this up, you just fix it, there's no ego involved, it's just a bug.
It makes security a private act of hygiene rather than a public act of shaming.
Perfect phrasing. And it frees up the human security team. They don't have to waste their time looking for the easy stuff anymore. The robot catches all the low-hanging fruit. The security experts can now spend their valuable limited time looking for the complex, logical business flaws that a robot can't possibly understand.
This all leads us to the bigger concept of democratizing security. Because if we are giving developers these automated tools and these risk checklists, we are essentially asking them to take on some of the security responsibility themselves.
We are, and that's a big cultural shift. But we have to be extremely careful. We cannot just dump the responsibility on them without also giving them the support and the tools to succeed. We can't just say, security is your problem now, you figure it out.
Right. The source is really clear on this. The key is making the right thing the easy thing.
This is the golden rule of what's now called platform engineering. You have to pave the road.
So talk to me about what that looks like, the idea of pre-approved tools.
Let's take authentication again. It is notoriously, famously difficult to write secure login code. You have to handle password salt, you have to use the right hashing algorithm, you have to manage session tokens, you have to prevent timing attacks. It's an absolute minefield.
If you ask 100 developers on 100 different teams to write their own login system from scratch, how many of them will get it perfectly right?
Maybe two. And even they will probably miss some subtle edge case. So the Infosec team shouldn't be in the business of reviewing 100 different bespoke login systems. They should be in the business of building one really, really good hardened login library.
A golden path, a standard component.
Yes. The central security team builds and maintains it. They say, here is the company standard auth library. We've vetted it. We've penetration tested it. It handles the encryption. It handles the tokens. It connects to our central identity provider. Just drop this 2 lines of code into your app and you are secure.
So for the developer, it's actually the path of least resistance.
Yeah.
It's lazier and faster to be secure than it is to be insecure.
Exactly. You're appealing to a developer's best instinct, which is to solve a problem efficiently. If using the secure pre-built tool saves me 3 days of coding my own risky version, I'm going to use the secure tool every single time.
And for the security team, this is a force multiplier. It changes their life.
Yeah.
Because if they see that an application team is using the standard auth library, they don't even need to review that part of the code.
They trust the library, so by extension, they trust the app's authentication. This is how you win at scale. You stop chasing every individual project, and you start securing the supply chain, the building blocks that everyone uses.
It fundamentally changes the job description of the InfoSec professional. It's a different career.
It really is. And I've seen this cause some existential dread in the industry for people who've been doing this a long time.
How so? What's the fear?
Well, the old job was compliance cop. You had a badge, you had a checklist, you had the authority to say no. It was a position of power. The new job is tool builder and consultant and teacher. You have to serve the developers. You have to build things that they want to use because it makes their lives easier.
That's a huge shift in power dynamics. You're not a gatekeeper anymore.
It moves from policing to enablement. But I'll tell you, it's a much more fulfilling way to work. Instead of being the person everyone hides from and avoids, you become the person who helps them go faster, safely. You're an accelerator, not a brake.
I think this is a perfect segue to the case study. Because every time I talk about shifting left and empowerment and agile security, I can literally hear a specific segment of our listeners grinding their teeth.
The folks in the heavily regulated industries?
Yes, the people in banking, in healthcare. The defense contractors. They're all sitting there thinking, this is adorable. This is a cute little story for a web startup. You think you could just automate security? We have external audits. We have laws. We have the government breathing down our necks.
The classic objection, compliance says we can't do DevOps. It's the #1 reason people give for not changing.
Well, the source material drops a case study that effectively nukes that objection from orbit. We are going to talk about the United States federal government, specifically an agency called 18F, and a project they built called cloud.gov.
And for anyone who doesn't know, let's just set the stage on just how incredibly painful federal IT security compliance is. We are talking about FISMA, the Federal Information Security Management Act.
And then the NIST Risk Management Framework, the RMF.
The RMF, it is a beast, an absolute monster of a process. If you want to launch a piece of software for the government, even a moderate impact system, not even top secret stuff, you are looking at complying with roughly 325 specific security controls.
325.
Yeah.
What does a control even look like? Is it just simple stuff like have a strong password?
Oh, no. It's incredibly granular. There are whole families of controls. AC1, access control policy and procedures. AU2, audit events. PE3, physical access control. For each one, you have to write in detail how you meet the requirement. How do you ensure that only authorized personnel can enter the server room? How often do you rotate your encryption keys? What is your documented process for sanitizing old hard drives before you dispose of them?
You have to write all this down and prove it.
You have to write a document called a System Security Plan, or SSP. This is often a Microsoft Word document that is hundreds, sometimes over 1,000 pages long. You have to detail your compliance with every single one of those 325 controls. Then an independent assessor reads it. Then they interview your team for weeks. Then they generate their own report, a SAR security assessment report. Then a relentless back-and-forth negotiation happens.
And the timeline for this whole process?
Historically, 9 to 18 months is pretty standard.
18 months after the software is already built.
Yes. So you finish writing the code, and then the code just sits on a shelf for 1.5 years while you argue with auditors about paperwork. By the time it finally launches, the technology is obsolete, and the team that built it has moved on.
It's the very definition of government waste and inefficiency.
So enter 18F. This is a digital services agency that was created inside the GSA, the General Services Administration. They are basically a team of modern technologists, people from startups, big tech, the open source world, who kind of parachuted into the government to fix these broken processes.
And they looked at this problem and built cloud.gov.
Right. They realized that every single government agency was reinventing this incredibly painful wheel. Every agency was building their own servers, writing their own 1,000-page SSPs, fighting the same 325 battles over and over again. So they said, what if we built a platform?
Technically speaking, it's a PaaS, a platform as a service. The source says it's built on an open source technology called Cloud Foundry, and it runs on top of AWS, Amazon Web Services.
But the technology isn't the real innovation here. Lots of people use that tech. The innovation is the compliance strategy. It's a concept they call inheritance of controls.
Okay, let's break this down because this is the magic trick that makes the whole thing work. It's really clever.
Think of your software stack like a layer cake. The bottom layer is the physical data center, that's Amazon Web Services. The concrete, the fences, the guards. The middle layer is the platform, that's cloud.gov. It's the operating system, the networking, the patching, the logging. And then the very top layer is your specific application code.
Okay, a 3-layer cake.
Now, look at those 325 controls again. A huge number of them are things like physical protection of the data center, fire suppression systems, perimeter fences, and security cameras.
If I'm a simple app developer writing code for the Department of Agriculture, I can't control the fence at the Amazon data center in Virginia.
Exactly. So AWS handles those controls. They document it. They get all the necessary certifications. 18F, running cloud.gov, then says, okay, we are hosting our platform on AWS, therefore we inherit all of their physical security controls. Checkbox ticked. That whole section of the paperwork is done.
Go on.
Then you move up to the platform layer, controls like operating system patching, log aggregation and monitoring, secure network routing. The cloud.gov platform handles all of that automatically. They document it once for the whole platform, and they get that authorized.
So if I'm the developer and I build my app on top of cloud.gov, I inherit all of that work too.
Yes. So when you, the developer, sit down to write your system security plan, you don't have to write about fences and you don't have to write about OS patching. You just write one sentence. We inherit this control from the underlying cloud.gov platform.
And the source gives some specific Absolutely mind-blowing numbers on this impact.
It's huge. Of the roughly 325 controls required for a standard moderate impact system, the cloud.gov platform handles 269 of them for you.
269.
That is over 80% of the compliance workload. It simply vanishes for the application team. It's just done.
So instead of writing a 1,000-page essay about how you manage fire extinguishers and rotate passwords, you just have to focus on the 50 or so controls that are unique to your specific app.
Things like, who are the users who can log in? And what specific data do we store, and is it encrypted? That's it. You only have to worry about your own code.
And what did this do to the timeline?
Right.
We went from 18 months of paperwork hell to what?
The source says teams are getting their ATO, their authority to operate, in weeks. In some cases, for very simple apps, days.
From 18 months to a few weeks.
It completely proves that compliance is not a valid excuse for being slow. The problem isn't the law. The problem is the architecture and the process. If you use a modern platform that handles the heavy lifting, you can move at startup speeds even inside the most regulated environments in the world.
And that ties back perfectly to the whole shift left idea. 18F shifted the compliance work left. They built it into the platform from the start so that thousands of developers didn't have to do it at the end over and over again.
Exactly. They made the right thing, being compliant, the easy thing. Now, the easiest, fastest way to get an ATO in the government is to build your app on cloud.gov. So everyone wants to use it. It's a virtuous cycle.
It's absolutely brilliant. But, technology and process are only two legs of the stool. We have to talk about the third leg, which is often the hardest. We have to talk about culture.
Ah, yes, the squishy stuff, the people part.
The stuff that actually dictates whether any of these great ideas work in the real world. The source suggests that to really make this stick, we might need a rebrand of the word DevOps to explicitly include security in the tent.
Yeah, there have been a few contenders for that over the years. DevSecOps is the most common one you'll hear. It just jams sec right in the middle there.
It's functional, gets a point across, but it's a bit dry, isn't it?
It is. It feels like a term that a committee came up with. It doesn't really inspire passion.
The one I really like, and the one the source spends some quality time on, is this term rugged DevOps.
Rugged. It evokes a very specific image, doesn't it? It's not about process, it's about character.
It is. It sounds like an outdoor lifestyle brand, rugged software. But it comes from a couple of pioneers in this space, Josh Corman and James Wickett, and they wrote something called the Rugged Manifesto.
I love this document. In a world of dry corporate mission statements and bland value props, this thing reads like a warrior's code or like a superhero's pledge. It has real teeth.
I want to read a few lines from it because the tone is so different and so fascinating. It starts with a personal declaration. I am rugged and, more importantly, my code is rugged.
And just note the personalization there. It's I. It's not the company is rugged or our team is rugged. It's a statement of individual accountability. I.
Then there's this line about longevity. I recognize that my code will be used in ways I cannot anticipate and for longer than it was ever intended.
That is such a profound realization for a software developer. We're usually so focused on the next sprint, on getting the code to work today, we don't often stop and think about it still running 10 or 20 years from now.
And this one directly acknowledges the adversary. I recognize that my code will be attacked by talented and persistent adversaries.
And that's the reality check. It kills the naive security through obscurity mindset. It assumes you will be a target. It's not a matter of if, but when.
And then the core promise, the core moral stance. I refuse to be a source of vulnerability or weakness.
I refuse. It's a choice. It's a statement of professional integrity.
Why do we need this kind of, almost dramatic language? Is it just for show?
No, I don't think it is. I think it's necessary to shift the professional identity of software engineering as a discipline. Think about other engineering fields. If you're a civil engineer and you design a bridge and that bridge collapses because of a design flaw, you can lose your license. You can go to jail. There is a clear professional standard of care.
You have a stamp.
Yeah.
A P-EEN designation. You are a professional engineer with all the responsibility that implies.
In software, we haven't really had that. For a long time, we've had more of a hacker culture. Move fast, break things, oops, sorry about your data breach. The Rugged Manifesto is an attempt to mature the industry. It's a way of saying, listen, software is now the critical infrastructure of the world. It runs our hospitals, it runs our power grids, it runs our entire economy.
So treating it like a casual hobbyist project is no longer acceptable. The stakes are too high.
Exactly. If you write flimsy, insecure code today, you aren't just creating a bug for your team to fix. You are creating a potential weakness in the very foundation of society. It sounds grandiose, but when you look at major infrastructure, it's absolutely true.
So rugged DevOps isn't just about using better tools or processes. It's about a fundamental shift in mindset. It's about accepting the weight of that responsibility.
It's about being a true professional. The last line says it all. I am rugged not because it is easy, but because it is necessary.
So we've covered a lot of ground today. I mean, we've gone from the despair of the 1.10.100 ratio to the automated hope of CI/CD pipelines. We've seen the federal government inherit their way to incredible speed, and we've looked at the warrior code of the rugged developer.
It's a full journey from broken to, well, rugged.
If I'm a listener, maybe I'm a manager at a large company, maybe I'm a developer on the front lines, maybe I'm just someone who uses technology every day. What is the one thing I should take away from all this? What is the so what?
I think the so what is that quality and security is just one critical dimension of quality. Cannot be inspected in at the end. It's impossible. You cannot bake a cake and then after it comes out of the oven decide to sprinkle the sugar into it.
Right, it doesn't work that way.
It just sits on top. It's gritty and it falls off. The quality, the security, it has to be in the mix from the very beginning. Whether you are building software or a business process or a physical product, if you treat safety as a final check at the end, you will always be slow and you will always be fragile. It's a universal principle.
And as part of that, we have to stop waiting for a hero to save us.
Oh, absolutely. The hero culture in IT, and especially in security, is so toxic. We celebrate that one brilliant security engineer who stays up all night, chugging Red Bulls, staring at log files to catch the hackers just in the nick of time. That isn't a strategy, that's a gamble. And eventually the hero burns out.
Or the hero quits and goes to work somewhere else.
And then you're exposed. We need rugged systems. Not just rugged individuals. We need processes that make safety the default. We need to build that golden path we talked about so that ordinary developers can produce extraordinary security results day in and day out without ever having to be a hero.
I want to leave everyone with a final thought to chew on. And it comes back to that line in the manifesto that we discussed. I recognize that my code will be used for longer than it was ever intended.
It's a haunting thought, isn't it?
It really is. I mean, think about the core banking systems that are running the world's finances right now. A lot of that foundational logic is COBOL code running on mainframes. It was written in the 1970s and 80s.
By people who are likely retired or have passed away, their names are just comments in the code.
But their code, their logic, is still deciding your mortgage rate. It's still moving billions of dollars across continents every single day.
It has outlived its creators by decades.
So as you go about your work this week, ask yourself this. The work you are doing today, the systems you are designing, the APIs you're building, even the shortcuts you might be taking to meet a deadline. If that code is still running in the year 2046, if it is protecting critical infrastructure 20+ years from now, does the way you are building it today look like professional diligence? Or does it look like negligence?
Are we building digital cathedrals that are designed to stand the test of time, or are we just throwing up digital shacks that we know are going to collapse on our children's generation?
That is the question. Shift left. Be rugged.
And thanks for joining us on the Deep Dive.
Stay safe out there.